The types of brick. The first is clay brick. Material use of clay brick is made from natural materials, range from soft and plastic surface deposit to hard mudstone and shell. The process of clay brick is mixing the finely ground clay with water, molding, extrusion or pressure into the desired shape, drying it and burning it. The shape of clay brick often should retain its original shape without undue shrinkage, weeping or cracking when the bricks are dried and fired, and the color is red firing. Next is calcium silicate bricks. Calcium silicate bricks also known as sand lime ataupun flint lime. Kalau kat India, calcium silicate brick dikenali sebagai fly ash brick. Material used is siliceous aggregate, hard calcium lime and water. Very fine aggregate. Majority akan passing 1.15 mm using test sieve. The ratio of aggregate to lime by weight is in the range 10 to 20. Lime mixed in a proportion of about 1 to 10 with sand, quartz, crushed flint or crushed siliceous rock together with mineral colorants. The process of calcium silicate brick is material are mixed and left until the lime is completely hydrated. The mixture is then pressed into mold and cured in an autoclave for 3 to 14 hours to speed the chemical hardening. The shape of calcium silicate brick is standard size as clay brick, and they are either solid or may have rock but not perforated. And the color of the brick is off-white color. Okey, seterusnya adalah sand cement bricks (SCB). Material used in SCB is Portland cement and sand. Common ratio between sand and cement is 6 parts of sand to 1 part of cement by volume, with maximum size of sand passing through 4.8 mm mesh test sieve. The process of SCB is you can molding by hand or by machine. Machine is operated either by electric power or mechanical motor and incorporated with the pressing machine. After removal from the machine, the surface of the brick are normally scratched and left to be matured on the pellets under sheet. Normally for the first 24 hours after removal from the machine, the brick will be kept wet by watering through a fine spray. Remove from the pellets after 2-day removal from the machine and allowed to mature for a period of 26 days. The colors of the sand cement bricks is light grey. Okay, next is concrete bricks. Material used in concrete bricks is made from a dry, small aggregates concrete. The process of concrete bricks is formed in steel molds by vibration and compaction in either an egg layer or static machine. The finished blocks are cured rather than fired using low pressure steam. The shaped concrete bricks is in terms as blocks and are available in many colors and typically pale grey. Mortar for brickwork. Mortar work is served to cushion the bricks unit, giving full bearing against one another despite their surface irregularities. The purpose of mortar is bond the brick together, to seal between the bricks against penetration by air and moisture, stick the brick unit to one another to bond them into monolithic structural unit, accommodate small movement within the walls and the appearance of the finished brick wall. Okay, next is mortar mix. Okay, mortar adalah composed of inert aggregate iaitu sand and a binding material of lime or cement or both. Okay, binding material ni adalah material untuk lekatkan brick. The proportion of cement and lime in the binder affect the properties of mortar and it can be carried out by volume or by weight. Selalunya mortar mix adalah based on ratio 1 binder to 3 aggregate. The reason is because the air space between particles of sand account for about 1/4 of the total volume. Okay, seterusnya adalah definition. Okay, mortar is a mixture of sand, cementitious materials and water yang digunakan untuk bond bricks. Cement lime. Cement lime ni adalah mixture of cement, lime and sand. Lime mortar pula adalah slate lime mixed with sand and water. Slate lime ni adalah calcium hydroxide, iaitu a soft white powder produced by adding water to quicklime. And slate lime ni used in making mortar and cement. Masonry cement ni adalah mixture of OPC, iaitu ordinary Portland cement, and inert pulverized limestone or hydrated lime. Slaking is the chemical reaction that produces hydrated lime when limestone and water are mixed. Sand yang digunakan must be clean and screened to eliminate particles that are too coarse or too fine. Change in sand type and gradation affect the workability of the mortar. Sands deficient in fine generally produce harsh mortars, while sands in excessive fine result in weak mortar. Water adalah mixing agent yang mana which add to workability, and without water, cement hydration and subsequent setting and hardening of the mortar would not be possible. The purpose of sand in mortar. Tujuan sand dalam mortar ni adalah bertindak sebagai filler yang mana akan meningkatkan strength dalam mortar. Yang kedua, reduce shrinkage, mana dia akan prevent the development of crack. Ketiga, assist in the hardening of pure lime by allowing the penetration of air, which provide carbon dioxide for the development of carbonization. Yang keempat, control dimensional stability. Dia akan retain its shape and thickness. Yang kelima, mengurangkan kos, iaitu sand lagi murah daripada lime and cement. Seterusnya adalah mortar joint. Mortar joint ni adalah narrow line with a conventional nominal joint thickness of 10 mm. Maksudnya, thickness mortar joint yang selalu digunakan adalah 10 mm. It account for over 17% of the surface area of the brickwork. For example, in English pond, about 20% of the surface area is mortar, while pond consisting for all headers of the proportion is nearly 25%. Brickwork is jointed by striking, breaking or rubbing the mortar while it is still green. Maksudnya, kerja-kerja brickwork ni akan menggunakan mortar yang masih belum kering. Ni adalah mortar joint profile, pattern mortar yang digunakan untuk join the brick. First is flush joint, reserve joint, weathered joint, key joint, weathered pointing, and red out joint. Yang ni pula the profile of pad joint yang kita tengok dari sisi hadapan. Next adalah video yang akan terangkan type of bricks based on raw material.
Types of bricks based on raw materials. Based on the raw materials used in the manufacturing of bricks, it can be classified into burnt clay bricks, fly ash bricks, concrete bricks, sand lime bricks, and fire clay bricks. Burnt clay brick. These are traditional bricks which are usually made from clay soil and burning them. The average compressive strength of clay bricks is as displayed on the screen. It is used in constructing a variety of structural members like masonry walls, foundation, columns, etc. Fly ash bricks. These bricks are made from Class C or Class F fly ash. The main ingredients of fly ash bricks include fly ash, quicklime or lime sludge, cement, aluminium powder, and gypsum. The compressive strength of fly ash brick is normally of the order of 7.5 Newton per millimeter square to 10 Newton per millimeter square. Fly ash bricks are lighter and stronger than clay bricks. These types of bricks are used in cost-effective and eco-friendly construction. Concrete bricks. These are made from cast concrete, that is Portland cement, and aggregates. Concrete bricks are generally manufactured as solid blocks or hollow concrete blocks. The compressive strength of concrete masonry units and masonry walls varies from approximately 7 Newton per millimeter square to 34 Newton per millimeter square. Generally, concrete blocks are heavier than the clay bricks. However, lightweight blocks can also be produced using autoclaved aerated concrete. Concrete block is commonly used in the construction of load-bearing walls of buildings. Sand-lime bricks. These bricks are usually a white brick made of lime and selected sands. Compressive strength of these bricks varies between 17 Newton per millimeter square and 21 Newton per millimeter square. These bricks are generally used for good acoustic insulation, good heat-humidity accumulation purposes. Fire clay bricks. Fire clay bricks are refractory bricks made from the refractory ceramic material. Fire bricks contain high amount of aluminium oxide as high as 50 to 80% with correspondingly less silica. The compressive strength of bricks varies between 3.5 Newton per millimeter square and 48.26 Newton per millimeter square. These bricks are generally used in lining furnaces, kilns, fireboxes, and fireplaces. These are commonly used bricks based on materials used in construction. Apart from these, some special type of bricks is manufactured with different materials based on requirements. Subscribe our channel for more civil engineering related videos.
Okey, video ni pula akan menerangkan pasal proses pembuatan brick.
Those three little pigs knew what they were doing when they built that brick house. Not only are bricks wolf-proof, they're also fireproof, pest-resistant, and weather-resistant. No wonder they're one of the world's oldest building materials. Bricks are often made of shale, a lightweight rock that splits easily into thin layers. Quarry machines dig 40 centimeters down to expose the shale to the elements for 2 years. This weakens it, making it easier to process once it gets to the factory. A 4-foot-high stone wheel with a steel tire grinds the shale into powder. It grinds up 50 tons of shale per hour. A screen sifts out any pieces that need more grinding. The powder goes to the pug mill, which mixes it with water. This makes a thick paste that will next go through the extrusion machine. The extruder forces the paste through a rectangular opening to form one long continuous piece called a slug. At the same time, it shaves off the crustier top layer to expose what will become the face of the brick. If this gray shale mixture is fired as is, it'll naturally produce a red brick. To engineer a different color, they coat the slug in sand mixed with an oxide mineral such as zinc or iron. Next, they texture the surface with a textured roller. This is just one of many popular designs. Then, a large knife comes down like a guillotine and slices the slug into 5-foot lengths. You might be wondering where those 3 holes came from. Well, remember how the paste goes through the extruder to form the slug? Inside are 3 pins. They make 3 holes designed to decrease the brick's weight. Out of each 5-foot length, they cut 20 3-inch bricks. The ones on the ends are uneven, so they go back into the mix to make new slugs. Next comes the delicate job of stacking these newly minted bricks to be. A machine first separates them. Then, using inflating bags, it grasps them, raises them, then stacks them. Meanwhile, the water in the bricks is starting to evaporate. To hasten that process, the bricks go into a dryer for 2 days. The dryer gets its hot air from the heat generated by the kiln, where the bricks go next for firing. The kiln is really a giant oven. It fires the bricks at 1,040 degrees Celsius. That's almost 2,000 degrees Fahrenheit. One and a half days later, the bricks are ready. The transfer machine takes them out of the kiln. But before they go to market, a technician does a quality check. He weighs and measures a sample to see if it meets the design specifications. Bricks are supposed to absorb some water, but not too much. Yet if they repel water completely, they'll also repel the wet mortar the masons use to stick the bricks together. So to test absorbency, the technician breaks a brick in half. He weighs it before and after soaking it in water for 24 hours. By comparing the weights, he can see how much water the brick has absorbed. Once the batch gets the okay, they stack the bricks into cubes of 500 to 600. Each brick weighs 5.5 pounds, so each cube weighs in at about 1/4 ton. Brick is one of the sturdiest building materials around. It doesn't rot, fade, warp, or dent the way some other materials can. Bricks are also energy efficient. They absorb heat to help cool your house in the summer and hold heat to help keep it warmer in the winter.
In this part of video, we will learn about brickwork bonding. In the brickwork, there are special terms that are used. The next video will explain the terms that are used in the brickwork.
Here are a couple of useful words to learn. A header is a brick laid horizontally, with its smallest surface toward the front of the wall. A course of headers is one in which all of the bricks are laid widthwise. A stretcher is a brick laid horizontally, with its longest surface towards the front of the wall. A course of stretchers is one in which all of the bricks are laid lengthwise. A mortar bed is the layer of mortar on which a course of bricks is laid. A perpend is the vertical layer of mortar at the joint between two bricks. They ensure that bricks in the same course are held together. A queen closer is a brick cut in half lengthwise. The quoin is the corner brick where two walls intersect. An essential rule which every bond follows is to always offset the perpends of neighbouring courses. This spreads the load evenly, preventing the risk of structural failure. As a result, most walls are made of alternating courses where the bricks are centered on the perpends of adjoining courses.
There is various methods of bonding are used, giving rise to different bond patterns which has special name. Firstly, header bond. Header bond has only headers in each course of a wall, normally used in the construction of footings and walls with sharply curved.
In masonry, a brick bond refers to a specific pattern of arranging bricks to ensure structural stability. It is determined by the position of each brick in every successive course of the wall.
Today we will understand about header bond. In this type of bond, all bricks are laid, with their ends towards the face of the wall. This type of arrangement is suitable for walls, which are 1 brick thick. This is also suitable for the construction of curved wall, and footings for better load distributions. Let's understand step by step with the help of animation. Firstly, we lay a base course for laying of course 1. In header bonds, the overlap is kept equal to half width of the brick. To achieve this, 3/4 brick bats are used in alternate courses as coins. After course 1, mortar base of 10 mm thick is placed. To know more in detail about mortar thickness, watch part 1 of brick masonry. Since header bonds lack strength and pressure transmission along the length of the wall, it is not preferable to use this kind of bond for load-bearing walls. I hope students I have made it clear about the header bond, with the help of this video.
Stretcher bond.
This pattern is used only for half brick thick walls. For higher thickness walls, this arrangement is not all practicable. In this type of bonds, all the bricks are laid with their lengths in the direction of the wall. To break joint at the end of the wall, a half bat is provided in exception, at each alternate course. Walls made with stretching bonds are mainly used as sleeper walls and partition walls. This is the top view of the first course in stretcher bond. You can see how bricks are laid on their lengths. After that, we start preparing base for second course, by applying mortar, 10 mm thick. Now, the course 2 is applied, and lap is provided between two courses, to prevent vertical joints. With a similar process, other courses in the wall are laid. Courses 1, 3, 5 are same in the 6-course wall shown here. Similarly courses 2, 4, 6 are the same. Stretcher bond is also known as running bond. The waste in this bond is less, as it does not require any header. This type of bond is best in making cavity walls, by creating 2 layers of walls with a gap between them, and tying them together at regular intervals. Cavity walls will be explained in my other lectures. Now, as all the 6 courses have been laid, let's understand about lap distance. For that, let's go to elevation of the wall. As we took the standard size of the brick of 9 inch by 4.5 inch by 3 inch, our lap distance will be 4.5 inch. That is the half length of the brick. Lap distance is used to break the vertical joints between 2 courses. If the vertical joints occur, the wall gets weak. To provide an adequate bond in the wall, if the construction of wall is to be continued in later date or after some time, tooting space is provided. For that, alternate courses are projected to the same distance as lap distance. Now, come to mortar joints, as they are made manually, so margin of error is more, you cannot determine the actual thickness of mortar joint. Therefore its thickness varies from 3 mm to 12 mm. Now, let's understand with the help of an isometric animation, the creation of a stretcher bond wall.
Bond.
What is English bond? English bond is the most commonly utilized type of bond in masonry works. English bond in brick masonry consists of alternate stretcher course and a header course. Headers are laid centered on the stretchers in the course below and each alternate row is vertically aligned. After the first header, a coin closer is used in the beginning and end of a wall to break the continuity of vertical joints. A coin closer is a brick cut lengthwise into two halves and used at corners in brick walls. This type of bond is used to produce strong 1 brick thickness wall.
Flemish bond. It comprises of alternate headers and stretchers in each course. There are two kinds of Flemish bond. For double Flemish bond, both external and internal faces of the wall have the characteristic appearance of Flemish. For single Flemish bond, it has a facing of Flemish bond with a short backing of English bond. It has a large number of short continuous vertical joints which occur in the longitudinal joints.
What is Flemish bond? In a Flemish bond, each course in brick wall comprises of alternate stretchers and headers. The alternate headers of each course are centered over the stretchers in the underlying course. Every alternate course commences with a header at the corner. Coin closers are generally introduced in alternate courses next to the header, for breaking the vertical joints in the successive courses. Flemish bond is significantly subdivided into two different types. They are single Flemish bond and double Flemish bond. Single Flemish bond is a combination of English bond and Flemish bond. In this type of bond, the front exposed surface of the wall is composed of Flemish bond and the back surface of the wall is composed of English bond in each course. Double Flemish bond takes the same appearance both in the front and back elevations. The disadvantages of using Flemish bond are it is complex and requires
Welcome back
greater
to the
skill to
class.
build up.
This is part 3b of Brick Bond series. In this part we will understand Flemish bond in detail, in different thickness of wall, and different junctions. Let's start with single Flemish bond. This type of bond is comprised of double Flemish bond facing, and English bond backing in each course. Thus, the advantages of both the types of bonds are incorporated in this type of construction. Let's start with course 1 layout in 1.5 brick thick wall. At the start of the course, 1 header and queen closer are placed, and after that, 2 stretchers and 1 header is placed alternately. At the stopped end, wall is finished in the same way as started. That is, with a queen closer and a header. Then we use a 3/4 brick bat to cover the queen closer and header. And after that, stretchers are placed along the length. At the stopped end in course 1, a 3/4 brick bat is used to complete the wall. At the other side of the wall, the stretchers are placed outside, and headers are placed inside, as shown in animation. The minimum thickness of the wall, where this type of bond is used, should be 1.5 brick. Now, let's understand the arrangement in course 2 of 1.5 brick thick single Flemish bond. In course 2 we start from a stretcher instead of header, and then we place queen closer and a 3/4 bat after that. Now, opposite to the course 1 in same side of the wall, we place stretcher inside, and headers outside to break the vertical joints. At the stopped end of the wall we use the queen closer, stretcher, and a 3/4 bat. It is the mirror of the arrangement we used in starting the brickwork in course 2. In other side of the wall in course 2, we place stretcher outside and headers inside, which is just opposite of the arrangement that was in course 1 in same side of the wall. Now, let's place course 2 above course 1, and see the arrangement of wall. From different view angles we can see that there are no vertical joints coming. Advantages of this type of construction is that it partly possesses the strength of English bond, and appearance of Flemish bond. The disadvantages of single Flemish bond is that it cannot be used for walls having thickness less than 1.5 brick. The construction requires skilled labor and careful supervision. In next part we will learn about the arrangement of double Flemish bond. Now in this part we will understand about double Flemish bond arrangements. Let's start with the arrangement of 1 brick thick wall in double Flemish bond. Here are the 2 courses of double Flemish bond in 1 brick thick wall. Left one is course 1 and right one is course 2. Besides the general rules applied in Flemish bond, which have been described in last part, there are several others, which apply particularly to double Flemish bond. There should always be a queen header in every other course. As we can see in animation, in one brick thick wall in course 1, a queen closer is used after a header. After that, alternately 2 stretchers and a header is placed along the length of the wall. At the stopped end, the mirror of the start of the brickwork is used, that is, a queen closer and a header. Similarly, at the other end of the wall, 2 stretchers and a header are placed alternately, starting from header. Now, in course 2 of one brick thick wall in double Flemish bond, we will start just opposite from course 1. Instead of starting from header and a queen closer, we will place a stretcher and a queen closer to start the wall. And after that, 2 stretcher and a header are placed alternatively. By doing this, each header in course 1 will come in the center of stretcher in course 2, which will increase the bonding in the wall. On the other side of the wall, bricks are placed in the same way. Instead, we will start from placing the header first, which is just opposite of what we did in course 1. Now, when we lay courses one above the other, in a 6-course sample we can see that there is queen header in every alternate course. The inside face and outside face of the wall is same. One brick thick walls are easier to produce a fair face on both sides in Flemish than in English bond, and that, in the opinion of many, the appearance of Flemish bond is preferable to that of English bond. Now, let's understand the arrangement of double Flemish bond in 1.5 brick thick wall. Here are the 2 courses of 1.5 brick thick wall in double Flemish bond arrangement. In course 1, we will start from a header, a queen closer, and a 3/4 bat. After that, the arrangement of header and stretcher are placed in such a way that there is a space of a half bat in the middle of the bricks, as shown in the animation. Similar arrangements of bricks are made along the length of the wall. Stopped end of the wall is made by a 3/4 bat, a queen closer, and a header, which is just the mirror of the arrangement we used in starting of the wall. On the other side of the wall, similar arrangement of header and stretchers are made with half bat in middle, along the length of the wall. When we come to course 2, instead of starting from a header, we start from a stretcher, then a 3/4 bat, and a queen closer. Rest of the arrangement is same by using a header and a stretcher, and providing a half bat in the middle, as shown in animation.
Garden wall bond. It is suitable for garden and division and be of 2 forms. Firstly is English garden wall bond. It has 3 or 5 courses of stretchers, 1 courses of headers. A queen closer is introduced next to coin, header in heading course. The header is placed at the coin of each middle. For the Flemish garden wall bond, it has 1 header to every 3 or 5 stretchers in each course.
Today we will learn about garden wall bond, where they are frequently used, and types of garden wall bond. This type of bond is suitably adopted for one brick thick wall, which may act as a garden wall or a boundary wall. In garden wall bond, it is possible to build uniform faces for a wall without much labor or expense. This type of bond is not so strong as English bond, and its use is restricted to the construction of dwarf walls, or other similar types of walls, which are not subjected to large stresses. On accounts of its good appearance, this bond is sometimes used for the construction of the outer leaves of cavity walls. There are 2 types of garden wall bond, mostly used. First is English garden wall bond. Let us understand the bond arrangement with the help of animation. The general arrangement of bricks in this type of bonding is similar to that of English bond, except that the heading courses are only inserted at every 4th or 6th course. Usually the arrangement consists of 1 course of headers to 3 courses of stretchers. A queen closer is placed next to the coin header of the heading course to give the necessary lap. Garden wall bonds are designed specifically to reduce the number of through headers to minimize the labor in selecting bricks of roughly the same length for use as headers. The reduction in the number of through headers weakens the through bond of brickwork to an extent. This is of little consequence in a freestanding garden wall. Other combinations such as 2 or 4 stretchers to one header may be used. For the standard English garden wall bond, headers are used as coins for the middle stretching course, in order to generate the lap, with queen closers as the penultimate brick, at either end of the heading courses. The heading course in English garden wall bonds sometimes features bricks of a different color to its surrounding stretchers. In English chalk districts, flint is substituted for the stretchers, and the headers constitute a lacing course. The tops of garden walls can be finished with one of the special coping bricks, or stone cappings. Let's continue on to garden wall bond. Now we will know about Flemish garden wall bond arrangement with help of animation. As you can see in the animation, course 1 is comprised of 1 header to 3, or sometimes even 5 stretchers in series throughout the length of the course. Each alternate course contains a 3/4 bat placed next to the coin header, to provide a necessary lap. After that same pattern is used, as was in course 1, which includes a placement of a header after 3 of 5 stretchers. Similar arrangements are used in all other courses. It is different from English bonded garden wall, as it includes headers every alternate course, which breaks the continuity of stretchers, as it is in English garden wall bond.
Dutch bond consists of alternate courses of headers and stretchers, but each stretching course begins at the coin with a 3/4 bat, and every alternate stretching course have a header placed next to the coin 3/4 bat.
What is Dutch bond in brick masonry? Dutch bond is a modified form of the English cross bond and consists of alternate courses of headers and stretchers. In this arrangement of the brick bond, each stretching course starts at a coin with a 3/4 bat. Every alternate stretching course has a header placed next to the 3/4 bat brick provided at the coin. This type of bond used to create strong corners along the wall. Dutch bond is used where corners of the walls are subjected to excess loads.
Pilaster is used for stiffening brick walls and to provide all or part of their lateral support. Pilaster is also known as attached pier. Piers, also known as pillars or columns, in brickwork used to support concentrated loads or to strengthen walls. There are many ways that dampness can penetrate into a building through the brick wall, and they are by during beating against the external walls and absorb the water to show dampness on the internal walls, moisturizing up the walls at or near to the base by capillary action and move up to the wall and enter the building above the ground floor level. And thirdly, moisture penetrates down into the head of the wall and moving down into the building below of the roof level. The above can be overcome by placing a suitable damp-proof course in the thickness of the wall. Damp-proof course, DPC. It is an impervious material placed horizontally or vertically to provide a barrier to the passage of moisture from the external source into the wall of the building or from part of the structure to another. Damp-proof course is normally placed at the distance of 150 mm to 300 above the ground level. The materials to be used as DPC should be completely impervious, should be durable and long-lasting, should be of thin membranes of sheet so to prevent disfiguration of the wall. It should be strong to support load impulse on it with the ends shooting out from the wall, and should be of flexible material and be able to deflect accordingly with any settlement without fracturing.
When bedding DPC, the first stage is to create a continuous full bed joint of mortar. This is to prevent the DPC from being punctured from any sharp edges. Once you have spread the mortar along the length of the wall, you can then roll out the DPC, making sure the DPC is positioned flush with the end and face of the brickwork. Once you have rolled out the DPC, you need to iron it out, keeping it flat. This can be done using the back of the trowel. The finished bed joint needs to be approximately 5 mm thick. Finally, once you have ironed out the DPC to the required thickness, you can then cut it to length using scissors or a sharp knife. Once you have cut it to length, clean up any excess mortar, especially any snots from within inside the cavity.
There are a few types of materials used for damp-proof course, such as lead, copper, mastic sulfide, bitumen, polythene, slate, and bricks. Metal anchors are positioned in the brick walls to provide structural integrity of the walls. It will attach a wall to its supports, either to the wall, floor, beam, column, or other structural support. Ties are one of the examples of a metal anchor which used to hold a brick walls together, while fasteners attach other building elements to the walls. Ties must be strong for its purpose.